Okay, this one has got a variety of different things going on. A little bit of standard A, a little bit of standard B maybe, and then a whole lot of standard C. So let's take a look at this first one. What is the greatest common factor of the terms in this polynomial? Well, we know this one, the 10 is a 2 and a 5, and we've got the 5x's. 4 is a 2 and a 2. 6 is a 2 and a 3. So it looks like they all have a 2 in common. And then 5x's, 4x's, 3x's, they share 3x's in common, so a 2x cubed looks like the one that we're looking for there. These, again, breaking them down, this is 2 squared times 3. This is 2 squared times 5. This is just 2 squared. So it looks like they have the 2 squared in common. And stacks of x's, they have 2 of those in common, so that feels like a 4x squared. Greatest common factor of this polynomial. This one's just a 3. This is a 3 times a 3. This is a 3 times a 7. So they all have a 3 in common. The x's, this has got 5, that's got 4, that's got 3. So they have 3 x's in common. It's got 4 y's, 5 y's, 6 y's. They have 4 y's in common. That is the greatest common factor of that polynomial. Just as, well, bonus information there, looks like that's a degree 9 trinomial. Just remind you of those things. Greatest common factor of this one, 15 is a 3 times a 5. This is a 2 times a 3. This is a 3 times a 3. So it looks like number-wise they have a 3 in common and 2 z's. So 3z squared is the thing. That's a quartic trinomial. All right, complete the factoring. So they've determined that they are going to take a 3 out of this. The way that we have looked at that with the boxes is to put the 3x and the 6 here, and or actually the 3x plus 6 goes in the boxes. Sorry about that. So 3x plus 6 is there. We've got a 3 on the outside. If that's going to be a 3x, the x must have come from there. There must have been a 2 coming from there. So that must be an x plus 2 that goes in there. This one, a little bit goofy looking one there. We're starting out with an x minus 5 in the boxes, and they're putting a negative, which is a negative 1, on there. There must have been an x here, and it must have been negative for the negative times negative to give us a positive. That is getting the negative from here. It must be getting a positive 5 from there. So that should be the opposite of negative x plus 5. We could have probably written it as 5 minus x if we wanted to, but this is standard form. Okay, factoring without the extra help there. We're going to go to this. We got a 12z and a minus 32. That's a 2 squared times 3. This is a 2 to the 5th. So it looks like they have a 2 squared in common. That'll put a 4 out there. So to get the 12, there must have been a 3. The z had to come from somewhere. Must have been up there. And the 4 times 8 is 32, and the negative must have come up from there. So this is equal to 4 times 3z minus 8. This area model over here is just a place to help us keep track of what was going on. It's never the answer in itself. Okay, a little work on this one. So this is a 2 times 3, a 3 times 3, and a 3. So it looks like my greatest common factor is going to be a 3, an x squared, and according to the y's, a y cubed. So this was a trinomial. So we need our box to have space for 3 things. This is going to have a 6, x to the 4th, y to the 4th in it. a 9x cubed y to the 5th, and a 3x squared y cubed. We found our greatest common factor was the 3x squared y cubed. Number-wise, 3, 6, that must have been a 2, right? There's the 2 once we take out the 3 from that. X squared, but this has x to the 4th, so there must have been 2 more x's up there. Y cubed, that's y to the 4th. The 4th one must have come from there. Everything's addition here. 3 to get the 9 must have been a 3. The x squared, x cubed, there must have been an x up here to get that third one. Y cubed, y to the 5th, there must have been 2 y's there to give us 5 of those. The 3, so nothing to match there. The x squared, the y cubed, all that is left there is a 1. So the factored form of this should look like 3x squared y cubed times 2x squared y plus 3xy squared plus 1. That should be the answer to that one. Turn the page. Okay, factor this. What they have in common, the 14 is a 7 and a 2 and an x minus 11. This is a 13, a 1, and an x minus 11. So x minus 11 is what they have in common. If we're going to do this with the box, then I've got a 14x and an x minus 11, and a 13 and an x minus 11. And we're going to take the x minus 11 out. So there's where it came from. The 14x must have come from up here. X minus 11, the 13 must have come from up there. So the answer here is x minus 11 times 14x plus 13. Okay, factor completely. This is where we may be kicking into some of standard C. At this point, we'll have to see what happens. That's a 7. This is a 7 times 3. I'm suspicious that maybe a 7 goes in there, so I'll use my calculator to try that, and I get 7 times 18 that I get there. And clearly 7 is going to be the common one. I know my 18 is 2 times 3 squared, but this didn't have any of that in it. So step number 1 is going to be to get this trinomial box set up here with the 7y squared minus 21y minus 126, and pull the 7 out. This one didn't have a y, so they don't have a y in common. That means this must have been a y squared to get the 2 y's from there. This is a minus 3, and the y came from there. And we figured out, based on this, that that must have been a plus 18. Okay. So now we're going to take this and try one of these boxes out with that quadratic trinomial. We'll throw the y squared in there. The 18 right there. We know that these two things have to add up to negative 3. 1 times 18, they need to multiply to 18. So I'm thinking of two numbers that when I multiply them, I get to 18, but when I add them, I get negative 3. A negative 6 and a positive 3 would fit the bill for that. So I'm going to put a negative 6y in one of these and a 3y in the other. These, as a greatest common factor, both have a y in them. If that's a y, then the other y must have come from there. If this is a 3y, then the 3 must have come from over here. If that's a minus 6y, then the... Ooh, this is not going to work out, is it? Because negative 6 times 3 is not negative 18. Oh, but this was a minus 126, so that should have been a minus 18 in the first place. And I'm feeling better about that now. This would be a minus 6, negative 6, positive 3, makes the negative 18 that was here to begin with. And so putting it all together, I pulled out a 7 to begin with, and then the box part of the factoring gave me a y minus 6 and a y plus 3. So that is completely factored. Okay, same deal here. It looks like common factors are going to be a 7x. Let's see, this, if I divide that by 7, I get 14. I get a 7 times 14 there. This is going to be a 7 times 40 there. They all have at least one x in them. So I'm going to pull a 7x out. And what I've got in here is a 7x cubed. I'm going to go ahead and write this as 7 times 14x squared and 7 times 40, like that. So this one must have had x squareds coming from there. This one, the 7 and one of the x's, so just one of the x's and that 14. And let's see, this had an x in it as well that came from here. The 7 and the x came from there, so the 40 must have been up there. Make our quadratic box and throw this into that, the x squared in the upper left, 40 in the lower right. We know that these need to add up to 14, multiply to 40, because the 1 here times the 40. And so numbers that multiply together to give me 40 and add to 14 feel very much like a 10 and a 4. So I'll throw a 10x in one of these and a 4x in the other. It doesn't really matter which way I put them. I can pull an x out of there, which means that must also have been an x. This must have been a plus 10 to make a 10x there. That must have been a plus 4. Double check, 10 times 4 is 40. So the factored form of this, first thing I did was grab this 7x and take it out. And then of the stuff that was left, I had an x plus 10 and an x plus 4. So that is the completely factored form of that. Okay, we're going to press on even though we're nearing 13 minutes here. Try this again. 40 is 2 cubed times 5. This is 2 times 5. This is just a 5. So it looks like my GCF is a 5. Put that outside of trinomial box here. I'll write that as a 2 cubed times 5x squared and a 2 times 5 times x and negative 2 times 5 times x. I'm going to make sure I see that. And a negative 5 in there. If 5 gets pulled out, I'm left with an 8x squared. 5 gets pulled out there, I'm left with a negative 2x. And this would be, if 5 gets pulled out there, I'm left with a negative 1. Okay. So now, here we go to the quadratic part. 8x squared, leading term in the upper left, constant term in the lower right. So need to add up to negative 2, 8 times negative 1, multiply together to give me negative 8. Let's see, 4 and 2 are 2 apart, so it feels like if I had a negative 4 and a positive 2, those would multiply to give me negative 8, add to give me negative 2. So one of these needs to be a negative 4x. One needs to be a positive 2x. I see that I can pull a 4 out of this. Okay, 4x out of there. That would make this have to be a 2x. If that's a 2x and that's a 2x, then this must have been a 1. If that's 4x and that's a minus 4x, that must have been a minus 1, and plus 1 times minus 1 is negative 1. So I started by taking out a 5, then I had a 2x minus 1 on the side of the box and a 4x plus 1 on the other side of the box. So there's my completely factored form. This one, because it starts with an x squared, a 1 there, there is no greatest common factor to pull out. Okay. So I can go straight to the box, throw an x squared in there, 7 down there. I need things to add up to 8, and when I multiply them I get a 7, because 1 times a 7, that feels like a 7 times a 1. And so I'll put a 7x in one of these and a 1x in the other. This has got to get an x from each side, a plus 7 from there, a plus 1 there. 7 plus 1 makes a 7. So this was an x plus 7 on one side of the box, x plus 1 on the other side of the box. That's the factored form of that. Again, because this starts with a 1, so these are basic level standard A, standard C, sorry. So because it starts with a 1, there's not a greatest common factor to pull out. There's not a variable in common everywhere. So w squared there minus 12. Need to add to negative 4. 1 times negative 12 is negative 12. Looking for numbers that I can multiply to get negative 12. But when I add them, I get negative 4. Negative 6 and a 2 would do the job. So negative 6x or 6w and a 2w. So w here, w there, minus 6 there, plus 2 there. 2 and negative 6 makes a negative 12. That all fits, so I've got a w minus 6 and a w plus 2 for the factored form of that. Oh, lights out. There we go. Okay, 6 more. Here we go. Again, no greatest common factor to pull out. So it looked like we hit our standard B with problems 11 and 12 back here. This was like standard B advanced, okay, where we had to pull out a greatest common factor and then factor the stuff that was left behind. So this was a Unit A B advanced, which is the most sophisticated part of the standards that we have in this chapter. Okay, x squared there, 42 there. Got to add to a negative 13, got to multiply to give me a 42. 6 times 7 is 42. If they were both negative, they would multiply to give me a positive 42 that add to negative 13. So I got a negative 6x in one of these, negative 7x in the other. Common factor is an x in both directions. Minus 6 there, minus 7 there. So this is x minus 6 times x minus 7 in its factored form. All right. The B version, I believe, here on this one. So check for greatest common factor, but this is a 3. This is 2's and 2's. So no greatest common factor. 3x squared, leading term there, constant term there. Feels like one of these is probably a 3x and one's an x, but we'll go ahead and do our process here. They've got to add up to 4. 3 times negative 4, this first one of these that we've seen, those multiply to negative 12. So we need two numbers that multiply together to give me a negative 12, but add to 4. That feels like a 6 and a negative 2 would do that. So we'll have a 6x and a negative 2x. Common factor here is a 3x on that, which means the x would come from there. If that's a 3 and that's a 6, that must have been a 2. It got the x from there. If that's an x and a minus 2x, that must have been a minus 2 there. And negative 2 times positive 2 is negative 4, so that all fits. And I get an x plus 2 on one side of the box, 3x minus 2 on the other side of the box. Okay, any greatest common factor? No, this is a 3. That's a prime number right there, and the other ones don't have that, so clearly not. Quadratic term in the upper left, constant term in the lower right. Got to add to the linear term, which is an 11, multiply to 3 times 10, which is 30. Feels to me like a 5 and a 6 would do the job there. 5 times 6 is 30, 5 plus 6 is 11. So we'll put a 5x and a 6x, or I guess they're y's. In this case, that was the variable. The only thing these have in common is a y. If this is going to be a 3y squared and that's a y, then the 3 and the y must have come from there. The 5 must have come from up there. This must have been a 2. It got a y from there. 3 times 2 makes a 6. And so that looks like a 3y plus 5 times a y plus 2 for the factored form of that. All right. 3 to go. 541 is prime. So no greatest common factors on these. We got 5w squared goes there. The 42 goes there. This one's going to be exciting. We've got numbers that need to add to negative 41. When we multiply these together, we get 5 times 42 is 210. So numbers that multiply together to give me 210 and add to give me 41. Now, what could be helpful on here, I know this was a 5, that 210 came from multiplying these things together. 42 is 6 times 7, so that's 2 times 3 times 7. So combinations of 5s and 2s and 3s and 7s, 10, for example, and 21 would multiply to 210, but there's no way. It looks like they're going to have to both be negative if it's going to multiply to be a positive and add to be a negative, and 10 and 21 would only give me a negative 31. Okay, so let me try some other things. If I put the 5 and the 3 together, that gives me a 15 and a 14. That's 29 when I put those things together. I think I see it. The 5 and the 7 give me a 35 and a 6. So that's going to be a 35 and a 6, a negative 35 and negative 6. We'll add to negative 41 and multiply to 210. So one of these is going to be a negative 35w. The other is going to be a negative 6w. This is 5. This is 5 times 7. So a 5w could come out of that, which makes that a w, which makes that a minus 6, which makes that a minus 7. The negative 7 times negative 6 is the positive 42. So my answer here is a w minus 7 and a 5w minus 6. All right, dos mas. 3, 11, 11's prime. So no greatest common factor. 3w squared minus 20. Got to add to negative 11. Got to multiply to negative 60. So one positive, one negative. And we may go back and take a look at this the same way we did before. So we've got a 3 here. We've got a 2 squared times a 5 there. So 3 and 5 is 15, and 2 squared is 4. That would work. If one of these was a 15 and one was a 4, and the 15 would have to be the negative. 4 times negative 15 is negative 60, and 4 minus 15 is negative 11. So 4w, a negative 15w. These only have a w in common, so the 3 and the other w must have come from there, which makes this a plus 4, and that a minus 5. Negative 5 times 4 is negative 20, so I have a 3w plus 4 and a w minus 5. All right, last one. These look like they're all divisible by 3. So 36 is 6 times 6, which is 2 2s and 2 3s. This is a 3 and an 11. This is a 2 and a 3. So we are going to start by pulling out a greatest common factor. So this is a U8B advanced happening here again. And what they have in common is a single 3. So if that 3 is gone, that leaves a 4 times 3. That leaves me a 12x squared. This is going to be a minus 11x. And this is going to be a plus 2. And now we will load up our quadratic box with the 12x squared. What I've got so far is I know a 3, 12x squared, and a 2. Got to add to negative 11. Got to multiply to 12 times 2 is 24. 8 and 3, I believe, a negative 8 and a negative 3 would do the job. So negative 8x, negative 3x. And this is 4 times 3, this is 4 times 2, so those have a 4 and an x in common, which leaves a 3x up there. 4 times 3 will make the 12 and the 2 x's. This would be a minus 2 to get that. This would be a minus 1, and negative 1 times negative 2 is positive 2, so this is a 3x minus 2, and this is a 4x minus 1. And finally,